a parallel plate capacitor having area A. So here a parallel plate capacitor whose each plate is having area A. Now, and separation small d, distance of separation between two plates is d, is charged to a potential difference V, means potential difference between two plates is V. The charging battery here is charged with the help of battery, and this charging battery is disconnected. Now, due to charging here, plus Q charges are deposited and electric field is set up like this. Now, the charging battery is disconnected and the plates are pulled apart. These two plates, they are pulled apart to 4 times the initial separation. So, separation between plates which was initially d, now separation between two plates is made 4d, means the new distance of separation d dash is equal to 4d. So, disconnected and plates are pulled apart to 4 times the initial separation. The work done to increase the distance between plate, what we have to calculate? The amount of work done to increase the distance of separation between the two plates. So, for that purpose, see here, as far as charge is concerned, charge remains same, area of each plate is same, electric field in a space between two plates, that also we will see. So, what is the initial capacity? Initial capacity C is equal to, initial capacity C is equal to A epsilon 0 divided by D, A epsilon 0 divided by D, and as far as the new capacity is concerned, C dash is equal to, because area is same, A epsilon 0 divided by, what is D dash? D dash is equal to 4D, and that is equal to C divided by 4. So, as the value of capacitor when D dash is equal to 4D, means when separation between two plates is made 4 times the original separation, then the capacitor reduces from C to C by 4. Capacitor, it reduces from C to C by 4, and as charge Q remains same, as charge Q is same, and we know C is equal to Q divided by V. C is equal to what? Q divided by V, and here C dash is equal to Q divided by V dash. Therefore, V dash is equal to Q by C dash, and here V is equal to Q divided by C. Now, see here, due to separation between the two plates, what happens to the potential difference across two plates? So, V dash is equal to Q divided by, now instead of C dash, what we can write? C by 4, means it is 4 into Q by C, means the new potential difference V dash becomes equal to 4 times of V. So, see here, new capacitance C dash is equal to C by 4 and new potential difference V dash is equal to 4V. To find out what is the amount of work done required to pull the two plates apart so that distance between them becomes 4 times d, we must first find out what is the energy stored in capacitor in two cases. Energy stored initially in a capacitor is half CV square, and the energy stored in capacitor after separating the two plates by distance 4d, it is E2 is equal to half of C dash into V dash square, that is equal to half of, what is the value of C dash? It is C by 4, and what is the value of V dash? It is 4V and its square. So, that is equal to half of C by 4 into 16V square. So, it is 4 ones are, then 4 fours are, 4 ones are and 4 fours are, that is equal to 4 times of 1 by 2 CV square. So, E2 is equal to 4 times of half CV square. Now, the amount of work done to pull the plate, amount of, see here, initially we are having this much amount of energy. After pulling the two plates, what is the energy that remains stored in a capacitor? It is E2. So, work done is equal to E2 minus of E1. that is equal to 4 times of half CV square minus of half CV square. So that is equal to 3 times of half CV square. 3 times of half CV square. Now put the value of C is equal to A epsilon 0 by D. So work done W is equal to 3 by 2 A epsilon 0, because this capacitor C is A epsilon 0 by D into what? V square. A epsilon 0 by D into what? V square. So out of 4 option, look at which option is correct. 3 by 2 A epsilon 0, 3 by 2 A epsilon 0, 3 by 2, see here, 3 by 2 A epsilon 0 V square by D. So option A is the correct option for this question.